Chapter 11, Wide Area Networks, Part 2. Well, in Part 1 of this week's lecture, we were looking at all kinds of different technologies that allows us to communicate on the WAN. Right? We were looking at plain old telephone service, frame relay, DSL, all that kind of stuff. Well, here in Part 2, we're going to continue that discussion. Only some of these technologies, not only will you have heard of, but you're probably using them right now. One of the most basic ones is, how about broadband cable? Cable internet provided by your cable company. Here in Maine, that's by Time Warner, who recently just became Spectrum. And you get your internet service along with your cable service. So I have to have the cable service run to my house. Now, this is a very common choice for home use. And honestly, the speeds can be pretty good. Right? They're talking here theoretical transmission speed, 100 megabits downstream. Here in southern Maine, I've maxed out on Spectrum's internet plan. I get 50 megabits down. Now, it's asymmetrical, just like DSL was. Remember this? So my upload speeds are much slower than my download speeds. But again, for the most part, I am sitting here downloading stuff, not uploading stuff. One piece of hardware that's common to cable connections is the cable modem. Right? This is a layer 2 device. Actually, it's a layer 1 and layer 2 device. And the input into this is going to be probably your coaxial cable coming in from your cable provider. Okay? The output can be any number of things. A lot of these cable modems are also firewalls, are also switches, are also NAT gateways, wireless access points. The one that's in my house has 4 switch ports on the back that I can plug into different nodes into. You can plug access points in. You can do all kinds of stuff on it. Right? Is this customer owned or provider owned? Well, it depends. It used to be that you had to rent your cable modem from the provider. Laws in recent years now says you can own your own equipment. However, if you own your own stuff, guess who takes care of it? You. Now, cable, although it's very commonly used for consumer, is also commonly used for enterprise, especially smaller enterprises. Right? Time Warner, business class, all that kind of thing. It costs more, but what you end up with, and actually a lot of times the speeds are the same. What changes is your service level agreement and your overall uptime and your support levels and all that. We'll talk about support levels here at the very end of today's lecture. Another WAN technology is asynchronous transfer mode, ATM. And I'm not talking about something that you get money out of. ATM is a layer 2 protocol that provides WAN connectivity. Now, we can go into all kinds of details about what goes on this, right? I mean, we could teach an entire class on ATM if you wanted to. The takeaways from it, well, I can get pretty fast. I'm talking 622 megabits, which across the WAN is really, really good, even at this time. I can emulate a LAN, so it allows me to emulate Ethernet over other types of networks. I have worked in one network environment where ATM was used internally on the LAN, and it did it with LAN emulation by putting Ethernet across it. Downside to this, though, it can be pretty expensive, right? A lot of times this can be implemented using fiber. It doesn't have to be, but it could be, which means I need not just a fiber NIC, but a fiber ATM card. So, and again, not the device you put in the machine to get money, a network card. But it's not a regular Ethernet card, it is an ATM card. If you're going to use this, you kind of need to want it and have a real reason for it. And it's going to come with a price tag. You might be lucky enough to live in a metropolitan area that has something called Metro Ethernet, Metro E. Think of this as Ethernet. It's the layer 2 protocol that takes place in our LANs, right? It's a standard on that. Well, how about an Ethernet network that spreads over an entire city, hence Metro E? This is in a way a metropolitan area network. Not all cities have them, But if you lucky enough to live in one, I mean, imagine this, right? You're off of this switch in the city, and your branch office is off of this switch in the city, and you're getting a 100 megabit connection across here, which is fast Ethernet. Slow for LAN networks, still pretty good for WANs. Well, I'm communicating across my two sites, my WAN sites, really over Ethernet, over an extended Ethernet with everything that goes along with it. Not available everywhere. A lot of advantages, though, if this is available to you. Another way, how about wireless WANs? How about places where I don't have Metro E, where I can't get DSL? Cable doesn't run out there. My last house I had outside of Dayton, Ohio, was in a cornfield, and I was unable to get cable internet because of the cable company didn't run out that far out in the sticks. I was more than 3 miles away from the telephone switching station, so DSL wasn't an option for me. I was pretty much looking at dial-up or satellite. We'll look at that one here in a minute. But then something happened. A wireless WAN opened up business, and they specialized in providing high-speed WAN service to these isolated areas. And they do it using this protocol, 802.116, called WiMAX. It's a radio signal, right? Notice this. I have a carrier's facility with a transmitter. I might have another tower somewhere. Sometimes these are cell phone towers I use for these. That, again, has a transmitter on it. And on the receiving end, on my house, well, there's my antenna right there connecting to it. I could also have an antenna mounted in my car. So as long as I'm in range, driving around in range of my transmitters, I get my WiMAX signal. As long as I'm even a mobile device, if I had something that specialized in that. And to be honest, I can't think of one, but I'm certain they exist. If I'm walking around in it, I can certainly do it. Clearwire was a company from about 10 years ago. They're still around, and they do stuff other than WiMAX now. They made their name by selling WiMAX. Wireless. They were a wireless ISP. Here's the one we're probably all familiar with. Cellular technology. Your phone, your iPhone, your Android, whatever. Cellular technology has been around for a while now, at least in the U.S. since the 90s. And back then, our cellular technology was this, 1G, analog. It was an analog signal. Remember when we talked about different signaling types weeks ago? Well, that's what it was. Think the old Motorola flip phones. Not a lot of data flying across that. There's not much web surfing. These things had like numbers. You called on them. If you were lucky, you sent text messages on it. But then as technology improved, we started ending up with digital transmission. Today, analog's about gone. And it just increased. 2G, look at our speeds, 240 kilobits per second. That's not much better really than, it's better than dial-up, but no, not significantly. 3G, 384 kilobits per second. And now look what we go in here, 4G, which is the common one that we see on our modern devices. I mean, 100 megabits, up to gigabit speeds, depending on what it is. Wow. This has totally changed our mobile experience. Now I can have an iPad with a 4G receiver in it, and web surf, and upload videos, and stream, and all this other kind of stuff. It's possible because of these cellular networks. If you're in the United States, there's two major technologies that provide cellular service, GSM and CDMA. And which one you get depends on what carrier you pick, right? AT&T uses one, Verizon uses a different one, and of course, they're totally incompatible with each other. The cellular network, well, it's a network. It's a wireless network. You have central offices, your signals get transmitted, and they get bounced from tower to tower to tower to tower. As long as your mobile client, aka your phone, is in range of one of the towers, you have a signal. The strength of your signal depends how much of a connection you get. I don't know about you, but if I'm in a nice strong area, I get 4G, this nice LTE signal, right? But when I start getting out more into a weaker signal away from cell phone connectivity, I might drop down to 3G, or even down to no G. It's just I'm in roaming mode. I'm extended. It means you don't have a signal. The further you are away from the towers and the weaker your signal, the slower your speeds. Another method, and this is one I actually had for a while in my house in the cornfield, is satellite. We use satellite all the time, right? We use it for satellite television, satellite radio. We have satellite radio receivers in our cars. It's very commonly used. Well, how does all this work? It is literally a satellite, a satellite orbiting the Earth. Now, the satellite has to be stationary in our sky. And the reason for that is because we can't have our antennas shifting across the sky. Your dish TV dish doesn't do that. It doesn't move. Your direct TV dish doesn't move. It points to one spot. And what it's doing is it's pointing to the spot in the sky where this satellite is right here. Well, that spot is called a geosynchronous orbit. And it's about 22,000 miles above the Earth's surface. And most of these satellites orbit right above the Earth's equator. Right? So if you know what latitude you are, and you know and you have the other measurements, you can figure out exactly where in the sky your given satellite is, and you point your dish to it. You use an uplink and a downlink. Right? So I'm going to have a base station here. I'm going to have a receiving station here. This station might be connected to the regular internet through whatever other technologies, everything from DSL to cable to whatever. And when it hits this station, it uplinks to the satellite. The satellite then in turn beams it back down to another receiving station. Now, a lot of times these receiving stations are located in places where you can't get other services, like my cornfield. I had a satellite dish on the side of my house that received this. Sounds like a plan, right? Great. Well, unfortunately, not so much. In my opinion, this is one of those in emergency break glass kind of things. It is totally true that with satellite, I can get high-speed internet anywhere on the Earth. Anywhere. When I was deployed overseas back in my military days, we had satellite connections. Want to get there? If it's going to be low on the horizon, get up to the North Pole, yeah, I can get satellite. Antarctica, satellite. I can get 10 megabit, 50 megabit, whatever coming down. But it comes at a critical cost, and that is latency. Radio waves are what? It's a form of light. Remember, we looked at that back weeks ago when we were looking at the spectrum. Well, the speed of light is 186,000 miles per hour. Or excuse me, 186,000 miles per second. What am I saying? Normally, that's pretty fast, but the satellite is 22,000 miles up. So for a signal to go from here to here, 22,000 miles, 44,000 miles, and then the reply, 22,000 miles back, 22,000 miles back. I have to travel 88,000 miles to send a signal to my base station and get a reply back. And that's not including my connection where it has to go on the regular internet connections across the Earth. Well, 88,000 seconds is just under half of 186,000 miles per second. So my latency on a single ping going up and back is almost 500 milliseconds, almost half a second. That sounds fast. And we have this on every kind of satellite communication. We just don't notice it when we're just streaming our stuff, like satellite radio or satellite TV. But internet is two-way. We're replying and sending and uplinking and downloading and all this kind of stuff. So my latency becomes real important to me. The type of things I can do with this become limited. Right? Imagine VoIP, voice over IP, across something like this that has half a second latency each time. It would be like, hello, pause, hello, pause, how are you doing? Pause. Really good, thank you. It's like talking to somebody on the moon. Things like online gaming, forget about it. First-person shooters, not going to happen. A lot of these things need latencies down less than 100 milliseconds. 50, lower the better, 20 milliseconds, right? Fast, fast, fast. 500, 800 milliseconds, whatever, it's not going to do it. This is a valuable tool. And it can provide high-speed internet pretty much anywhere on the planet. The downside is that one is expensive. It is one of your more expensive methods of connecting to the internet, and it has that high latency built into it. If everything else went according to plan and everything always worked, we could stop right now, but it doesn't. Things break. When we're talking about WAN issues, it's not so much figuring out what the problem is, it's figuring out where the problem is. You're the network administrator. You're going to get a call from one of your users one day, and it'll be something along the lines of, the internet is broken. Please fix it. Okay? Well, the internet's not broken, more than likely. It's a connectivity problem to the internet. Question is, where is it? Is it in our local area network on our equipment, or is it an ISP, a provider's problem? And quite frankly, that is the source of a lot of contention, right? The first thing you're going to do is start troubleshooting. The human impulse to say, it's not my problem, it's this person's problem. It's not ours, it's the ISP. The ISP will say, well, it's not our problem, it's your internal environment. What it comes down to is solid troubleshooting. Troubleshoot it out. Figure out what side of the circuit it is. Now, that's no guarantee it's going to solve your problems. I've seen cases where disputes like this went on for weeks between a provider and a client, each saying that the problem was on the other side. And in that case, it turned out to be the ISP's problem. Just because they're the ISP and the master of the wide area network doesn't mean that they're always right. Just be prepared, though, that you'd better make a strong case for that the problem is not on your side, and be prepared to defend it when you call in your problem. You have some other things you need to consider with your ISP also. A lot of times, and depending on the type of company it is, you might be subject to fair access limits. Satellite does this commonly, especially consumer-grade satellite. There's a limited amount of bandwidth traveling through that bird, right? And the idea is that everyone who signed up for the service is all paying that premium price for it. They don't consider it fair for one customer to be hogging all the bandwidth from everybody else. So what they do is they set up this thing called fair access, and you're going to be limited. When I had it 10 years ago, I was limited to 400 megabits down or megabytes down every day. That's not a lot. Even back then, that wasn't a lot. So that's something you have to keep in mind. You might be under utilization limits. Cellular providers, until very recently, data caps. They're actually still there. They're just kind of masked. I mean, I can't just download all the data I want at full speed. And that's our second item right here, throttling. Your provider might decide to start throttling down your speeds based on your usage. So if you're sucking down a bunch of data, if you're using 50 gig a month, let's say, they might say, you know what, we need to, and you're getting it at 50 megabits down, they may not cut your data off. But what they might do is throttle you down to some much lower speed. And in a lot of cases, depending on what it is, you can be dialed down to like dial-up speeds. You're still connected, it's just not fast enough to be able to do those data hogging activities like streaming video and music and stuff like that. Or they could just turn around and block you. You used up too much data. You're done for the month. We're shutting you off, period. It varies company by company, technology by technology. But for home use also, but especially in your enterprise, you need to talk to your ISP. Find out what these things are. Are there utilization limits? Do you do throttling? Do you block stuff? Do you engage in quality of service? Right? Do you enable certain kinds of traffic to have higher priorities than others? Right? Certain types of data traffic over streaming video, let's say, or whatever. There's no right answer to it, but you as the admin need to know what you're buying. And that is a wrap on wide area networks. As always, if you have any questions, please feel free to reach out. And I will see you next week.